Let's dive into a fundamental concept in calculus. What is an integral? You might have wondered, how can we calculate the area under a curve on a graph? Look at this graph where we have a simple function, f of x equals x squared, plotted. We're interested in finding the area under this curve between 2 points, say from x equals 0 to x equals 2. To do this, we can start by approximating the area using rectangles. We divide the area into smaller sections and sum up the areas of these rectangles to get an approximate value. As we increase the number of rectangles, our approximation becomes more accurate. The integral takes this process to the limit, where the number of rectangles becomes infinite and their width becomes infinitesimally small. This gives us the exact area under the curve. In mathematical terms, we're finding the definite integral of f of x from 0 to 2. The definite integral is denoted by the symbol, integral from 0 to 2 of x squared dx. Here, dx represents the infinitesimal change in x. By evaluating this integral, we can determine the exact area under the curve. For our example, the integral from 0 to 2 of x squared dx equals 8/3. Now that you've seen how integrals work, I encourage you to ask more questions about this topic. What if we had a different function or limits of integration? How would we evaluate more complex integrals? Let's explore these questions further.